Hello everyone. I hope you are doing well. In today's video, we are going to explore one of the most important technologies in the modern world, the internet. We will discover how the internet was invented, why it was created, how it evolved over the years, and what actually happens behind the scenes every time you open a website or send a message. Without wasting any time, let's get started. Guys, have you ever stopped for a moment and wondered what actually happens when you type www.youtube.com into your browser and then press the enter key? Within just a few seconds, a web page appears on your screen, and then you click on a video and it all starts almost playing instantly. Then you send a message to someone living thousands of kilometers away and they receive it in a less than a second. It all feels so natural that we rarely think about what is happening behind the scene. But have you ever asked yourself a simple question? How does all these activities work? How they actually work? So you should know how can your phone communicate with another device on the other side of the planet? How does information travel across oceans, continents, and cities in just a few moments? More importantly, who invented the internet and why was it created in the first place? Guys, believe it or not, the internet was not originally built for watching videos, scrolling through social media, or shopping online like we today. So, its story began long before smartphones, websites, and even our personal computers that became part of our everyday life. To understand how the internet works today, we first need to travel back in time. The story begins during the late 1950s, a period known as the Cold War. During this time, the United States and the Soviet Union were competing in science, technology, and military power. Governments realized that the communication was becoming one of the most important parts of national security. Back then, communication systems were highly centralized. Even if a major communication center failed because of a war or a natural disaster, a large portion of the entire network would stop working. This was a serious problem because reliable communication was essential for military operations, scientific research, and government activities. At the same time, computers were very different from the devices that we use today. They were enormous machines that occupied entire rooms and they consumed huge amount of electricity, and they were so expensive that only governments, universities, and research laboratories could afford them. Even more surprisingly, these computers worked almost completely independently. A computer at one university could not easily exchange the information with a computer located somewhere else. Researchers often had to send the magnetic tapes, punched cards, or printed documents by the physical transportation, which makes the collaboration slow and inefficient. Scientists began asking an important question: what if computers could communicate directly with one another? That single question, guys, eventually changed the world. While searching for an answer, researchers developed one of the most important ideas in the networking: that called packet switching. Yes. So instead of an entire message as one large block sending that, they decide to divide every message into many smaller pieces called packets, and each packet would contain a smaller part of the information along with the destination address. And these packets could travel through different routes and they can later be reassembled into the original message after reaching their destination. And this idea made the communication much more reliable even if one route became unavailable. The remaining packets could simply travel through the another path. This revolutionary concept laid the foundation for everything that we know today as the internet. And the first practical implementation of this idea appeared in 1969 when the United States Advanced Research Project Agency developed a called computer network called ARPANET. Initially, ARPANET connected only four computers located at four different research institutions in United States. So on October 29, 1969, researchers attempted to send the word login from one computer to another. However, something unexpected happened. After sending only first two letters, L and O, the receiving computer crashed. Although the experiment failed, those two letters became first message ever transmitted over what would eventually evolve into the modern computer. So over the following years, more universities and research organizations joined the ARPANET as different computer networks began appearing around the world. Another challenge emerged. Yes, assume each network spoke a different language. Imagine try to having a conversation where one person speaks English, another person speaks Japanese, another speaks Spanish, and nobody understands each other. Then that time computer faced the same problem. So to solve it, two computer scientists, Winsor and Bob Cannon, and they developed a universal communication standard called TCP/IP, which stands for Transmission Control Protocol and Internet Protocol. TCP/IP gave every network a common language and it defined how information should be divided into packets and how device should be identified, how data should travel across the networks, and how the missing information should be recovered. On January 1st, 1983, ARPANET officially adopted TCP/IP. This date is widely considered the birthday of the modern computer because from that moment onward, different networks could communicate using the same set of rules. So, a year later, another major problem was solved. Every computer on the internet had a numerical IP address. While computers could understand these numbers, people found them extremely difficult to remember. Imagine trying to memorize a long numerical address every time you wanted to visit your favorite website. So, to make the internet easier for humans to use, domain name system or DNS was introduced. DNS worked like the internet's phone book. Instead of remembering complicated numerical address, people could simply type names such as youtube.com or google.com, while DNS quietly translated those names into the IP address behind the scenes. Then, in 1989, another breakthrough changed everything. Yes, a British computer scientist named Tim Berners-Lee introduced the World Wide Web that we know as WWW. We know it as short form, and many of them you know its full form also. That we, that I already said. So many people believe that the internet and the World Wide Web are the same thing, but they are actually different. The internet is the global network which helps in connecting billions of devices. The World Wide Web is a service that runs on the top of that network, which helps in allowing people to access websites through web browser using HTML, HTTP, URLs. Without the internet, the web could not exist. Without the web, using the internet would still require complicated commands instead of simple websites. So, as the 1990s arrived, the internet became available to the businesses and ordinary people. You can see this content that what I was saying. So, what I was saying, yes, as the 1990s arrived, the internet became available to businesses and ordinary people. Websites appeared everywhere. Search engines helped the users to find information within seconds. Emails transformed communication. Online shopping changed the businesses forever. And later, broadband connections, Wi-Fi, smartphones, cloud computing, and social media completely reshaped everyday life. Today, billions of people depend on internet every single day. But this raises another fascinating question: what actually happens when you visit a website? So, while I was explaining, just see these contents also. Okay, let's imagine that you type www.youtube.com into your browser. Although you see the word YouTube, your computer does not understand names. It understands only numbers. So the very first thing your computer does is contact a DNS server. The DNS then searches its enormous database and then finds the IP address associated with the YouTube. Once your computer knows the destination, it sends your request to your internet service provider, commonly known as your ISP. Your ISP act as the gateway connecting your home or mobile devices to the global internet. So instead of sending your request as one large block of information, this request is divided into hundreds or even thousands of tiny packets, and each packet contains part of your request along with the source address, destination address, and the sequence information. These packets, now you should know, the journey truly begins. Now, these packet travels across the internet through numerous routers. Think of routers as intelligent traffic controllers. Every router examines each packet and decide which route will deliver it most efficiently. And interestingly, not every packet follows the same path. Some may travel through one city, while others may take an entire different route. Regardless of the path they follow, all packets eventually arrived at the same destination. Many people imagine these packets like flying through satellites. However, that is not how the most internet communication works. Yes, the majority of international internet traffic actually travels through the thousands of kilometers of fiber optic cables laid across the ocean floor, and these incredibly thin glass cables transmit information using pulses of light, which allows the enormous amount of data to move across continents almost instantly. Eventually, your packets reach the YouTube server. A server, we should know, is a powerful computer designed to receive requests from users around the world, and the server locates the web page or video that you requested and then prepares the information and then divides it into thousands of packets before sending everything back. As these packets return, they may once again travel through different routes before reaching your device. Finally, another technology called Transmission Control Protocol or TCP checks every packet carefully. It ensures that nothing is missing, which so that the every packet arrived successfully and that everything is arranged in the correct order. So these are the responsibilities of TCP, Transmission Control Protocol. And even if one packet is missing, TCP requests only that missing packet again instead of downloading the entire web page from the beginning. Once every packet has been assembled correctly, your browser displays the web page. All of this happens in just a few seconds. Every search, every video, every online purchase, every email, every message, and every video call depends on this incredible sequence of events, which is which is taking place behind the scene. So, from connecting just four computers in 1969 to connecting billions of people today, the internet has become one of the humanity's greatest inventions. It has transformed the education, healthcare, business, science, communication, entertainment, and almost every aspect of the modern life. And perhaps the most fascinating part is this: every single time you click on a website, this extraordinary journey begins all over again, silently, visibly, and in just a matter of seconds. The internet may feel simple from outside, but guys, behind every click lies decades of innovation, brilliant, brilliant engineering, and one of the most remarkable technology achievements in human history. So, so guys, if you enjoyed learning how the internet works and discovering its incredible history, so I only give one advice: learn also from these notes. And thank you for listening to me. Goodbye.